In a previous video, we described how to structure and work with script Mfiles. Script Mfiles. In this video, we will do likewise for function Mfiles. So we're going to study here function Mfiles. As you'll see, function Mfiles, unlike script Mfiles, allow you to specify input values. So in function Mfiles, you can specify input values. When you run them from the MATLAB command window or from another Mfile. Now you already know how to define functions via the @ syntax. That was what we called anonymous functions. Anonymous functions. But that's only good for a one-line function definition. So this works if you have a one-line function definition. For more complicated functions, you need to set up a function Mfile for more complicated functions. Like a script Mfile, a function Mfile is a plain text file. So you'll see we write them in plain text. And those files should reside in your current directory or elsewhere in your MATLAB path. Okay, now I'm about to present an example of a function Mfile which I will use to run some Monte Carlo simulations of an experiment to test whether you are the smartest person in the room. So we're going to run some Monte Carlo simulations. If you're not familiar with that phrase, you'll see what it is in a moment. But first, I want to tell you a little bit about logical expressions and MATLAB programming. So logical expressions and MATLAB programming. MATLAB actually assigns values to logical expressions. It assigns the value 1 if the expression is true, and the value 0 if the expression is false. So for example, at a MATLAB prompt, if you type 2 is greater than 1, then MATLAB will respond with a 1, because 2 greater than 1 is a true logical expression. On the other hand, if at a prompt you were to type 1 is greater than 2, then MATLAB will respond with a 0, because this is, of course, 1 greater than 2 is a false MATLAB expression. Now sometimes you can combine this feature with MATLAB's random number generator to measure the frequency of an occurrence of an event. So let's see how that goes. Okay, I'm now going to make use of MATLAB's random number generator combined with a little bit of MATLAB programming that makes use of the way that MATLAB responds to logical expressions. So as it says here, the command randi, that's right here, it generates a 1 by s matrix with randomly chosen integers between 1 and 10. So here's your matrix, 1 by s. The 1 is implicit. The 10 tells you that it generates integers between 1 and 10. So there will be s of them. One would expect approximately half of them to be bigger than 5. If one measures the percentage of those that are actually bigger than 5, for samples of larger and larger size s, one expects the percentage to be closer and closer to 50%. So let's see. The first thing I do is set up a matrix 1 by 10 and put 1s in all the entries. And then here's a little loop. I let s go from 1 to 10, and then I generate my 1 by s matrix, each of whose entries is a random number between 1 and 10. Now here's the interesting command. I define a new matrix B as follows. I look at R, it's the 1 by S matrix, and I compare it to 5. So for every entry in there, all S of them, it compares to 5. If it's bigger than 5, it puts a 1 there. If it's smaller than 5, it puts a 0 there. So B will be a 1 by S matrix containing only 1s and 0s, and there'll be a 1 wherever the original matrix has a number bigger than 5, and a 0 wherever the number is smaller than 5. I then, for each S, add up the 1s and divide by the number of places. And in that way I get the percentage of entries which are bigger than 5. And then the last thing I do is display T as a column matrix. So let's run this baby and see what happens. Of course the result is in the MATLAB window. And there it is. So actually 2 times we didn't get any numbers bigger than 5. And then here's here we got that many and more than half, about half. Not so surprising given that S is a relatively small number. You should of course appreciate that if I run this again, I'm not going to get the same thing because it's a random number generator. Let's just illustrate, run it again. And this time we get somewhat different numbers. They spread around fairly far, because 10 is not a very big number. That's not a large enough sample space. And so let's do it now for bigger values of S. So this time I'm going to let S run between 101 and 110. But I'll only measure between 101 and 110, so I only need a 1 by 10 matrix. Exact same thing as before, random numbers. I measure the ones that are bigger than 5, and I compute the percentage. And we should see numbers closer to 50%. Let's see. Yep. But still varies between about 44% and 62%. And again, if I ran it again, I'd get somewhat different numbers, but they'd still be closer to 50%. Finally, even bigger S, this time I do it for 10,000. But again, only between 1 and 10. 10,001 to 10,010, otherwise it's the same. And we would expect this time the numbers to be even closer to 50%. If I run it, and there they are. So pretty close, huh? We're down almost 1 decimal place. But not identical to 50%, but quite close. Okay. So this is a simple example combining MATLAB's response to logical expressions, its random number generator, and some very simple MATLAB programming. But in the above, which incidentally I could have typed into the command window at the cost of a lot of time, I had to keep re-entering command lines with different parameters. You see that above, right? I had to keep changing the parameters. It was a little bit tedious. And a better way is via a function mfile. And so we want to see how to implement a function mfile so that I don't have to keep re-entering parameters with different values. But instead of redoing the above, I'm going to look at something LOOK, a little more interesting, again involving random numbers, but ones that arise from a normal rather than a uniform distribution. Okay, here's our function mfile. You will see that it's a single file with just text entry. The first line contains the word function. This tells MATLAB that what follows is a function mfile. Then is specified the independent variables, 3 of them here, q, n, and k, and the dependent variable labeled here r, and the name of the function mfile as well as the name of the program, in this case smartest. You should always save a function mfile with the same name as the name of the file, and here it is, smartest.m. It's then followed by what are called the help lines. They're basically comment lines which explain what the function mfile does. So in this case, it computes the likelihood of a person who has an IQ equal to Q being the smartest person in a room containing K people. And then it repeats the process n times and outputs the probability based on these trials. Follows what comes next is your code, which can be interspersed with comment lines as well. It's a pretty slick short code here. They're just 3 lines. The first line uses the command random. The command random is found in MATLAB's statistics toolbox. We haven't talked too much about toolboxes here, with the exception of the symbolic toolbox. The toolbox which allows you to do symbolic computations, and we've done some of that already. Anyway, this is from the statistics toolbox. The first entry tells MATLAB which probability distribution to use. So in this case, we're going to use the normal or Gaussian distribution, which is how IQs among a group of people is distributed according to the normal distribution. And typically with IQs, we assume that the mean or average IQ is 100 and the standard deviation is 15. And then it will set up an n by k matrix of these values. There will be n rows, and in each row there are k entries representing the k people in the room, and each of those entries is the IQ of that person, selected randomly according to the normal distribution. So all these words basically say the same thing. The first entry to random tells MATLAB to use the normal distribution. Second is the mean. Third is the standard deviation. And now the suggestion is to type help random to see what other probability distributions you can use. For example, the binomial distribution or the uniform distribution. Okay, so I have now my random matrix. Each row is the IQs of the person in the room, and we do this n times. Think of n as a big number. And then there's just 2 lines of code. So what are we doing here? This line says for each entry, compare it to Q. If it's bigger than or equal to Q, then it gets a 1. If it's not, it gets a 0. Now, for you to be smarter than that person, it needs to be a 0. You don't want them to have a bigger IQ than you do. And then it sums all those numbers. The 2 here says sum along the rows. So it sums up the numbers in each row. So think about what will then be a column matrix, each entry of which will be the sum of zeros and ones in that row, corresponding to whether you're smarter than all those people or not. The only way you're smarter than everybody in the room is if every one of those entries is a 0. So then finally we add up the number of zeros and divide by n. So this will give you the percentage of times for which you are the smartest person in the room. Okay, it's time to run this function Mfile and see indeed when you are the smartest person in the room. I bring up the MATLAB window, and I'm going to run the function Mfile for various choices of the input variables. But before I do that, let's note here, this bar always tells you your MATLAB current directory, and that directory should be the same as the one in which the function Mfile is saved. Okay, so now I'm going to give you an IQ of 115. 5 people in the room, you're just with a bunch of friends, and we run 10 trials. Let's see what percentage of the time you're the smartest person in the room. 40% of the time. Let's do it again. Bring it up. That was the up arrow key just to bring up the previous command, and this time only 20% of the time. 10 is not a very large sample. Let's increase the sample size to 1,000. That'll give us a more accurate percentage. So again, 5 people in the room, you have an IQ of 115, 1 standard deviation above the mean, and the probability is about 42%. Do it again, 45, 46%. So it's not even a 50-50 bet that you're the smartest person in the room. You need a higher IQ. Let's increase your IQ up to 120. And the chances are better that you're the smartest person in the room. Let's run it again. Yeah, about 60%. Okay, that's not bad. But if now you're in a bigger room, say a classroom with 30 classmates, and your IQ is 120, what are your chances of being the smartest person in the room? Not so good. Not good at all. as you can see. So we need to increase your IQ. Let's get it up to 130. And you're still in the classroom, and now your chances of being the smartest person in the room are a lot better. You have 2 standard deviations above the mean, and it's about 45–50%. But let's again increase the size of the room. Let's make it 435, the number of members in the House of Representatives. Now, I don't want to make any suppositions about the intelligence of those people, but let's suppose you're in a room with that many people and you have a standard deviation 2 above the mean for your IQ. What are your chances of being the smartest person in the room? None. Again, none. You have virtually no chance. 435 people, even with 2 standard deviations above the mean, you're not going to be the smartest person in the room. There is no chance. However, finally, let's increase your IQ to 160, 4 standard deviations above the mean, and even in the august House of Representatives, you're virtually certain to be the smartest person in the room. So this is a very nice application of function Mfile. There's the file again. Just with a flick of a finger, you can change the parameters very easily and run the experiment over and over and over again. And this is a nice illustration of the use of function Mfiles. So let me next make a few general comments about function Mfiles. Here's the way they look. The first line is the word function, the independent variables, the dependent variable or variables, and file name, function file name. Next, you have some help lines that start with a %, explains what the function does, your code, which could be interspersed with comments. A couple of points, all lines containing MATLAB commands in a function Mfile end in a semicolon. I'll go back and show you the function Mfile again in a moment. And if you type help with the file name at a command prompt, then the help lines are displayed. Not the other comment lines, but the help lines themselves, those that appear under the function line that start with a %. And you should also see the MATLAB book, Differential Equations with MATLAB, specifically Chapter 4, for more information on function Mfiles, especially those with multiple output variables, which I haven't discussed here. Common variables in a function Mfile are local. Unlike variables in a script Mfile, or those defined in a command window, the variables in a function Mfile are unrelated to those previously defined, either those defined in a command window or in a script Mfile. MATLAB does not remember them after the function Mfile has been executed. It is for that reason, and to avoid spurious intermediate data spewing across your screen, that all command lines in a function Mfile should have their output suppressed by the semicolon. Otherwise, things could get a bit confusing. Again, here's the function Mfile, and notice in the 3 command lines, this one, and this one, there are semicolons at the end of the line suppressing the output. Thus, if we run a command, here's an example, we get 0 in this particular case, but none of the other intermediate steps are displayed, and MATLAB doesn't know the variables, doesn't know A, R, B, or S. On the other hand, if you do something like this, you set the output to a variable, then it does know T. Finally, if you type help, if you type help smartest, then you get the help lines in the function Mfile. And finally, if you type smartest, to type it correctly, it types out the results, the contents of the file. That's it.